All right, we're going to talk about rational equations and their end behavior. Essentially, a rational equation is nothing more than two rational expressions written in the form of a ratio or an equation, or a fraction is what most people think of it. And so what I'm going to do is I'm going to enter in two polynomials, one on the top as the numerator and one on the bottom. And then we're going to look at the end behavior. In other words, what does it look like as x approaches positive infinity and x approaches negative infinity? So if you look at my rational expression here, notice that the top polynomial, or the numerator polynomial expression, is the same degree as the bottom, as the denominator. They're both raised to the same degree. Now what that behavior does is when I go towards x towards positive infinity and x towards negative infinity, we study the behavior of the curve. If I change some of these numbers around but leave the degree of the polynomial the same, notice that it doesn't change the behavior too much, other than it creates a horizontal asymptote at the ratio of the leading coefficients. So when we look at this, so what am I saying? The limit of this function as x approaches positive infinity basically states we're going to guesstimate what the value of this function will be as we zoom out towards positive infinity in the x direction. So if I were to zoom this function out, in other words, if I let x go to positive infinity, what that would do is it would just go on forever. But notice that the y value doesn't increase or decrease. So as I slide out, my graph seems to hit like a plateau, or actually a horizontal asymptote that it can't cross. Now the reason for that is that the leading coefficients, the ratio of the leading coefficients kind of remain the same. Whatever my leading coefficient for the numerator is over the leading coefficient of the denominator, if the degrees are the same, establishes that horizontal asymptote. If I change these numbers, it will shift the graph vertically up or down, but notice that there seems to be a vertical asymptote that occurs, or not vertical, a horizontal asymptote that occurs at the ratio of the leading coefficients. The reason for this is that both polynomials, both the numerator and the denominator, because they are equal in degree, they grow at the same rate. In other words, as x increases on the top, it also increases the same amount on the bottom. The plus or minus numbers at the end of it doesn't matter, because we really want to focus on the highest degree within the numerator and the highest degree within the denominator. And if those two degrees are equal, then the numerator and the denominator are going to grow at the same rate. And it'll never cross that horizontal asymptote. Now let's take a look at a function if we choose to have different degree polynomials for the numerator and for the denominator. So what I'm going to do here now is I'm going to graph a different function where the denominator has a higher degree than the numerator. Again, any term beyond the highest degree as x approaches infinity really becomes irrelevant. It's that leading term, because it's the highest power, that's going to have the most impact. So if my denominator has a higher power, that's going to reach positive infinity quicker than my numerator, which has a lower power. In other words, as x gets bigger, the denominator is going to grow faster than the numerator. And so this is not the most formal way to say it, but basically the denominator is going to reach infinity before the numerator reaches infinity. And so as we zoom out and look at the behavior as x approaches infinity, we see that it's still a similar straight line or a horizontal asymptote, but the horizontal asymptote kind of occurs at 0. Now as we zoom in close, we're looking at the behavior on the inside, but again, we're not really worried about that. We're looking at end behavior in this particular exercise. So if we go towards negative infinity or positive infinity, we see that we grow very close to 0 for our y value. I wonder what would happen if we were to have a higher degree in the numerator than in the denominator. So let's graph that and see. Keep in mind, really what we're looking at is the rate in which the numerator and the denominator grow. So we said if they grow at the same rate, you'll have a horizontal asymptote, which is the same ratio of the leading coefficients. And in our last example, we said that if the denominator grows at a faster rate, it approaches 0. And now we have a numerator growing at a faster rate than the denominator. So in that case, what happens is that the numerator is going to reach infinity before the denominator. And if we zoom out, what we'll see is that as x approaches infinity, my y value also approaches infinity. And in this particular case, the same thing as x approaches